Okay, then we continue. About aggregate functions, it's similar like the idea of relational algebra. It's a set of functions that allow you to get some information or summarize some information about multiple rows into a single one row, multiple tuples into a single tuple, except of course if you used a grouping, then you will group this result into multiple rows of result depending on the group item. The aggregate function here, we have count to return number of rows or number of tuples in the result. Okay, in the query. You could use any select statement with any where condition, then count how many tuples you have in the result. You can use summation to calculate summation in the result for one of the attributes, or get the maximum value or minimum value, or get the average. Okay, I think grouping is important, except in some cases, or it's important in some cases that creating group for sub of the tuples that you want to summarize the information about it. For example, I need to get the average salary for each department. Okay, average salary for each department. Then, if you select all the employees and department, join between them. Okay, even in the employee itself, if you select all the tuples from employee and get the average, now you get the average for all the employee. To get the average for different or for each department, you will make a group using department number. So you will take the average for all employee for each department. This is a grouping. Okay. Also, we can use having clause. It's like using where clause, but this applied for the result of the aggregate function. So having a clause to get conditions that I don't need every result from the aggregate function. For example, I want to get information about departments that have more than 2 employees. So like this, you can check, use having, that's the count, the number of employees more than 2, and so on. We will take examples. So aggregate function can be used in the select clause. We mentioned that SQL statement have many parts. Each part we called it a clause. So we have the select clause, select star, select X, select Y, from this the from clause, where this the where clause, and so on. So you can use aggregate function in the select clause to get result of the aggregate function, or in having a clause to make like condition with what type of result from aggregate functions that you need. So example, here I need information from employees like the summation of the salary, the maximum salary, minimum salary, and average salary from employee. What's the result here? The result will be the summation of the salary for all the employees, the maximum salary from between all the employees, the minimum, and the average salaries for all the employees. Okay, why? Because I don't have here any grouping and any condition. I could have condition to take specific tuples before making the aggregation, or I can use a group to make the aggregation for specific group, or I can use having to make the aggregation in specific condition if I have specific result from this aggregate function. So like this, we make aggregation for everything. What's the result? The result will be one row or one tuple. Why? Because I don't have any grouping. Of course, same like relational algebra, we can rename the result. We rename the result here in select, actually in any type of clause or any type of a query in the select, for example, or even during the form clause, you can give also name for the relation or for the table, new name. Same thing here. In the result of the selected statement, you can give a new name for the result. For example, sum salary, as this mean renaming or give a new name. Total salary, maximum as highest salary. So in the result, it will be like this. Total salary, highest salary, and so on. The new names that we give here, and then the result. Still, we have one row result because we don't have any grouping here. Okay, this is some examples from aggregate function, but we have to know that aggregate function discard null values, so any null value will not be calculated from aggregate function. So if you are using aggregate function to count, for example, something, if it's have null value, it will not be counted. If you are making average and some value null, it will be only discarded. Why? Because if you have 5 values, for example, 5, 10, null, 5, let me set another null like this. The average will be only for the values. Null value will be discarded. This means 5 plus 10 plus 5, it's 20. 20 divided by 3 items. It's almost 6.5. 0.6, something like this, the average. But if you said null value will not be discarded, it will be problem because you will have 1, 2, 3, 4, 5 values. It will be different. So any null value will not be calculated from aggregate function. It will be discarded. Okay, so here.
Doctor,
okay.
the count, when we say, for example, count salary, count or number of employees, the null will count it or not?
I said not, because it will be discarded.
Okay.
Any null value will be discarded when you use aggregate function. Okay, then we have in this example, we need to get summation for the salary, for maximum salary, minimum average, for department named research. If we remember, let me just open this, I think here. Okay, if we remember here that the name of the department, it's here in department, in the department relation or department table. Here's the name, the name. But we are speaking about the salary, which is here. So first, to compare the name, we need to make a group, join between department and employee. The join condition will be D number here and D and O here and D number here. Then we can make the aggregation. So we need to make join. Why? We need to make join because the name of the department, which is research, it's in the department table. So we made here join between employee and department. What type of join here? Anyone remember the names of the join? Let me ask you, is it outer join? Is it outer join? No, outer join named outer join. So you have left outer join to have everything from all the tables from the left table. We have right outer join to have all the table from the right table. We have full outer join, so it will be named like this: left outer join, right outer join, full outer join, full outer join to have every table from the left and right. If they apply that join condition, it will be in the same table. If not, we will fill the left with null if we have value from the right, and we will fill the right with null if we have. I already mention everything about this and give examples and also even out example so you can return for it. Okay, then this not outer join. Is it the natural join?
It is inner join.
Sorry?
Not natural join.
Why not natural join?
Equi join.
let me ask you, why not natural join?
If the name of the attributes is the same, we can say it is natural join.
Okay, good. So because D number here and D and O different, not the same name, so it's not natural join. Okay, it's inner join actually. We have inner join, outer join. The normal join, we called it inner join. Okay, so it's inner join between employee department and the condition, which is equal join condition D and O equal D number. You can use it directly inside the where, because we said inner join can be like this. You mention directly the join, or can be like this. You can write it in different way. Instead of making join here, you can put the condition of the join. You can set from employee, comma, department, where you can put the condition of the join here directly. D and O equal D number. It will be the same result. Why? Because this one equivalent to inner join. It's same result. Okay, we return here. Where D name equal, so we make join between these two tables. It become one table. Then we can now just get the tables that have D name equal research. So after that, we can make summation and maximum salary, minimum salary, average salary for all employee of research department. Okay, this example just retrieve total number of employees, count, doesn't matter count what, so count start from employee. This will count all the rows in the result. In the company and number of employees in research department. So same idea here. Here we use the join, inner join. Here we write the inner join like where in the where clause here. D and O equal D number and D name equal research. So especially in our join, we have two ways to write it. We can mention join directly in the from clause, or we can put the join condition in the where clause without mentioning the keyword join. Okay, what about the grouping?
Sorry, doctor. In the previous
Yes.
class slide, the Q21, select count star from employee.
21, yes.
Yes. The solution of this question or of the above query is the Q22. Why we write these two sentences? And it is enough. We said select count star from employee department where.
We don't need any condition. We said just count the number of employees of our company.
But the question said, and the number who work in the research department.
No, this is Q22.
Oh, okay. It are different.
We have two queries. Retrieve
Yes.
total number of employees in the company. This query 21. And another query, the number of employees in the research department. So it's one query which is answered in Q21 and another query which is answered in Q22.
Okay. So, because I thought this was like a listed query. Okay, clear now. Thank you,
Yeah.
Doctor.
Okay, about the grouping, it's like you can imagine it like I need to make aggregate, but before this aggregate, I will divide the or make partition of this table or this result from the query into groups, and then for each group I will calculate the summarization function or make summarization for the information. So it will apply the function or get the result for different groups. In this case, here without the grouping, we have only in the result one row, one tuple. When you use aggregate function, result will have only one tuple or one row. But if you use a group, it's depend on the number of a group. For example, if you are grouping use department number and you have 3 departments, this means the result will have 3 rows. Row for each department number and then summarization for or the result of the function for each department number. If you are grouping, use, for example, project number, then you will have one row for each project, then what's the result of the function for each row or for each project number, and so on. So in this example, we have 2 examples. We need to focus in the difference between these 2 examples. And we have some issues in the grouping. First issue, the attribute that you will use in the group by should appear in the select. So you cannot say, for example, group by dname. Why? Because dname not in the result of the select. So the grouping item here or the grouping attribute must appear in the select clause. This first issue. Second issue, we will speak about if we have a grouping by one element or more than one element. If we have a grouping by one element, it's okay, we know it. If we have a group by 2 elements, this means when you will consider these 2 elements as one element. For example, if we have here E1 and E2, element 1 and element 2, and we are making grouping for E1, E2, just example, just to show you what I mean. For example, 1, 1, 1, 2, 2, 1, 2, 2. If you make a group with these 2 elements, it's different than making a group for only one of them. You will use these 2 elements as a block. So 1, 1, it's different than 1, 2. So this first group, this second group, this third group, this fourth group. Okay. But if we use only one element, for example, E1, now it's you will have different. When we use this two item, we had 4 groups. But if we use one item for grouping, which is E1, so we have this two similar, this two one group, and this two similar, which is another group. So we will have 2 groups. Then we can calculate inside each group the aggregate function. We will give example in detail for this. So in this example, we are counting number of employees and get the average salary for each department. That's why we make a group by D number. This means bring the employee for each department number, then calculate the aggregate function. Calculate the number of employees and give me the average salary. What about the round? Because average salary usually double value, so it will have point, I think it will have after the point around 8 or 6 digits. So I just make round for 2 digits. I take only 2 digits after the point, okay, or the comma. This is the meaning of round. So the aggregate function, it's average salary. And after get the average salary, I just make the number to get the result to get only 2 digits after the point, okay? Point, 2 digits. What's the meaning of rounding? Anything over 5 will be rounded up. Anything down less than 5 will be rounded down. So if you have, for example, 5.358 and you round it for 2 digits, this one more than 5, it will be added here as 1. So the result will be 536. But if you have another number here, 6353, when you rounded it to 2 digits, it will be like this. Only 0.35. Okay, this is the idea of round the number. We focus here only in the group. We need the grouping to get these values for specific group. Here another example. We have the project number, project name, and count. This means we are counting number of employees for each project, but we need to get the project number and project name in the result. And we will group for each project number and project name. Here, if you have unique project name and unique project number, it will not make any difference to make a group by the B number alone or B name alone. But if one of them not unique, for example, if you have project number, one can have more than one name or something like this, then here the different. In our example, it's difficult to get data like this, so I will give example using X and Y to show you the different, or some data from here to give you the different. Anyway, we make a group as a block, B number with B name. If we have different B number and B name as a block, so it will be a different group. So if we have B number 1 and B name A, and in another row we have B number 1 and B number A, so this one group, because we have same block B number plus B name. But if we have B number 1 with B name A and another B number 1 with B name B, so this two different block of the grouping. So this one group, this another group. I think the idea very simple here. Okay, so grouping by X means put all of those with the same value of X in one group. If you're grouping by X and Y means put all of those with the same value of both X and Y. So same value as a block X and Y with one group. Here, focus in this example. We have subject semester attend. Okay, so we have subject number, same subject number, and this different subject number, and this subject in different semester. Here we have this subject with semester 1, this subject with semester, same subject with semester 1, then same subject with semester 2, and so on. So we will see the difference if we make a group by subject only, or if we make a group by subject and semester. So first example, we are counting a grouping by subject. How many subjects we have here? We have one subject and another one subject. In this subject, we are counting. So we have two groups when we are grouping by subjects. One group, another group. Now, when we make count as aggregate function for different group, we will count rows. Only count rows. We have 1, 2, 3, 4, 5. So when we have subject IT B 0, 0, 1, count was 5. And when we have subject MK B 1, 1, 4, we have 1, 2. So the result will be 5 and 1. This grouping by only the subject. Okay. If we want to make a group by subject and semester, of course, it should appear in the select. So let us check the blocks of subject and semester. This subject with semester 1. So this first group, and this subject with semester 2, this second group, and this subject with semester 1, this third group. So we have 3 groups Okay, for a group, first group, we have 3 elements, so the count will be 3. And we have subject and semester. We have subject IT P001. When we have semester 1, we have 3. We have IT P001. When we have semester 2, we have 2 elements, 1, 2 in this group. This one 3, this one 2 also. So we have 2 when we have this subject MKP with the semester 1. So this is different. We consider this 2 elements as one grouping block, and then we see the different values for each grouping block. Then we can calculate summary function count or average or anything else. I think it's you already understand the point, or something did not understand it. Someone, sorry. Okay, so we have also some conditions that we can apply for the result of aggregate function use having clause. So having a clause from its name, having. So this select statement or this query should have a specific condition or a specific result in the aggregate function. If to do this, we should not must, we should use a group by before it to differentiate between different group. If you did not use a group by, it will work for you, the SQL. It will not give you any error, but it will not give results that you need, okay? Because it will be similar like the condition in the where clause. But usually we use have clause as condition to eliminate some group that did not apply, or to reject some groups that did not apply a specific condition. For example, here, for each project on which more than 2 employees work, retrieve the project number, project name, and number of employees. So we need to calculate this for different projects. That's why we have a grouping for project number and project name. But if the number of employees, so we count number of employees, more than 2, we don't need the information from this project. So we will reject a group result if the number of employee more than 2. To make this, we have same like query 22, I think, or 25, which will return number of employees and project name, project number for all the projects. But we need this number of employees for each project, so we will use a group by project number and project name. Okay, and here project name exists in project, but employees, okay, in the work on. So we will connect or join between a project and a project number works on. Then we grouping only by project number to count employees in each project. Okay, good. Now we will put one condition only. If count more than 2, this means only the result. When we have count more than 2, this means this project have more than 2 employees. We need the result. If it's have less than 2 employees or 2 employees and less, we don't need the result. So for each project on which more than 2 employees, this means we will have the result only if the count more than 2. That's why we're using have. Have to check the result. It will be used to check the result returned from the aggregate function. And the reason for using have is to reject or eliminate a group from the result. Okay, we have another keyword here in SQL, which is case. From its name, we use case when we have different values and we want to apply something or make some condition based in different cases or different condition. We can use this case in any part of the SQL when we have expected value, like in queries, like in inserting and updating. Actually, we almost use case when we are inserting or updating to check the value that we need to insert or update it. Okay, here in this example, we need to give employees different raises in their salary depending on the department. So, for example, if employee in department 5, we will give them 2,000 raise for the salary, plus 2,000. If the employee in department 4, we will give 1,500 raise in the salary if in department, and so on. So in this example, we will update. Update, this means we speak about values. And then we have cases to update these values. So we will update employee table and set the new value for the salary in these cases. What's the cases? When department number 5, then salary equal salary plus 2,000. This means if department number 5, then the new salary of the employee will be the old salary plus 2,000. And so on. When department 4, then we have this salary. When department 1, we have this salary. And case statement should have end. This is the case and this is the end of the case. In some books, you will not find this end. When you try to apply the query, you will get error, but you will not understand where is the error. Okay, so case statement should have int.
Doctor, that means case is related to update. We cannot use case without update.
Oh, you heard what last thing?
I am asking
We
about
get some problem.
Okay, yes.
Okay,
Now we
I
can
will
hear you.
return
Okay.
speaking about case another time. I don't know if you heard me when I give example for case.
Doctor, we hear you tell where you reach end.
Okay, good. Then you get the point here.
But I have a question. Can I ask now?
Okay, go ahead.
The end is related to the sorry, the case is related to update. That means we cannot use case without update.
No, we have, you can use case for select also. In this example, you can see select case. You can use case for update. You
Yes.
can use case for insert also. So it's simple idea. I will do something here after then, depending on condition. So we have case, when, condition, then what we will do. Maybe we will not change anything value in the database, only values that return from the select. This will affect the database update. And if you use insert also, it will affect the database. But here, for example, we have select statement. It will affect the result of the query. So the printed result from the query, but it will not affect the content of the database. So in the select statement, we have select from, and you can have condition also for this select statement. In the select statement itself, we can use case. Why? Because we expected values to return from the select statement. Here, what we said, when a value can be, or when we expected value, and if we have value to be affected in the database or returned from the database, we can make different condition using case. Okay, so we expect values to be printed or returned from the query select. So here we just return the first name, salary, and we make case when the salary more than 0 and less than, this means between 0 and between 25,000, we will print low salary. Where we will print low salary? Here you can give a new item here in the select statement case, it int, and after int we give the name of this attribute. So it's like you are returning something from aggregate function or something like this. So this, you have this group for the case. It will return specific values depending on condition. So you will name this value in the result. So salary, this means I have first name in the result, I have salary, and also I give the result of this case name salary group. So I have salary group. What's the result here? Here, first name of the employee. Here, his salary. So this come from where? Come from employee. Then salary group from where come? It's depend on each case. Each one give you cases. So we have 1, 2, 3 cases. So it could be this case, low salary. It could be normal salary. It could be high salary, depending on the condition. If the salary of this employee between 0 and 25, this will print here low salary. If between 25 and 40, this will print normal salary. If more than 40, this will print high salary. Let's try this one. Okay, so we have the examples for today. I think it's already here. So if we want to update the salary, let me, before updating the salary, let's select star, it doesn't matter, or let me select F name, L name, and salary from, okay, from employee. Okay, check the result. Here we return first name, last name, salary for all employees. Now let's give this employees raises. Let me also select the D number, DNO. So as this example, we will apply this example first to give raise for employees depending on their department number. So we have department number 5 here. Let's check these values. Okay, I will give raises for this employee depending on department number. This query, let me just open it. And I will close this one. So it will be like this. Okay, here I said update employee. This will affect the database. Set salary, new salary, depending on these 3 cases. If department number 5, if department number 4, if department number 1, the salary equal all salary plus 2,000 plus 1,500 plus 3,000. Okay, this previous values. Now we executed the query. 2 tables already updated. Now we increase the salary. Let's use select another time. We want to retrieve the data to check. Okay, here, department 5, we already increased 2,000. Okay. For department 4, we increased 1,500 and so on. So it's for update. Now we will see another query here. This query said, let me just open it before. Okay. We select department number, first name, salary, and we have cases if salary between 0 and 25,000, we will print low salary, and 25 to 40 normal salary, more than 40 high salary. End of the case and the name of the printing from this case. This means the name of the attribute returned from this case. So we will have 1, 2, 3, 4 attributes from this query. Let's check the result of this query. Okay, salary group. Why it's a problem here? I don't think there is any problem. Yeah. Just kidding with us, yes, no problem. Okay, so we have here normal salary. Why? Because it's between 25 and 40. High salary because more than 40. Normal salary, okay. Low salary because it's less than 25. And so on. This is a way of using case. Okay, then this every time we add for the block structure of the select statement or the query. So we now have select attributes from table list where conditions and select statement at least have this two. Select from where. So then after that you can add all this optional. Even the where clause, it's optional. Where condition group, grouping attributes, having a grouping condition for accepted group. Order by attribute list. Order by different than group by. When we saw that if we have two elements in the order, we order in first element, then inside first element, we order second element. But the group by, if you have two elements, this means you consider these two elements as one block. So different values for both elements will make different group. Okay. Okay. Sometimes and some issues that you cannot define in ER diagram and in relational model, and you need it. For example, if you have some restriction for the example, if you said if you enter date, it should be next of our before today. So you are doing like a transaction in the bank, okay, and you give a day for tomorrow. You need to check those conditions. So you said if the date that you entered more than today, this means this transaction will be rejected. For example, you cannot give salary for employee more than his manager of the department manager. So you every time you need to insert or update the salary, you have to check it if it's more than the manager's salary and so on. So sometimes you have some constraint that bind the scope of ER diagram and relational model, and you want to apply this constraint. You can use two ways. Create assertion and create trigger. Create assertion, using create assertion, you can specify additional types of constraint which is outside the built-in relational model. In relational model, you can give a constraint for referential integrity, for domain, for entity integrity, and so on. But some conditions that you want to check, you can use create assertion for it. We will give example. And also you can use create a trigger to make automatic action in a specific event or a specific condition. So for example, if you enter salary more than employee salary, you will give alert for the data entry person that you are entered salary for employee more than his manager, and so on. So it's depend the triggers. It's depend on the event make automatic action if the database perform specific or certain event. We will take the triggers, but assertion unfortunately not exist in PostgreSQL. So we will speak about it, but we will not apply example directly for our database for PostgreSQL. Why? Because create assertion not exist in PostgreSQL. Why not exist? Because PostgreSQL depend more in the triggers and PLSQL, procedural language query or procedural language SQL. We will speak about the procedural SQL. Okay, next lecture, inshallah. So create assertion not exist in PostgreSQL. It's allow you to make some conditions and some check for the data before insert or update it. For example, here, it's like create some event in the database. Every time this action will be done in the database, this create assertion will be checked by the DBMS, the system itself, database management system. Okay. For example, we said the salary of the employee must be less than the manager. This one example. So we create assertion. This the keyword create assertion. Then we give this assertion any name. Check. This what the assertion check. It checks that not exist that employee and his manager and the salary of the employee more than the manager. Okay, now we have two types of employee, normal employee and manager. How to know the manager? Manager of the department. Let me just here. Okay, stop sharing again because it's not full screen. Okay. So to know the manager department, we have MGR/SSM of this department and the manager, which is employee SSN. So we have two copies from employee table when it's normal employee and when it's manager. How to know this is manager? When his SSN equals the manager SSN of the department. So we can see this here. Here, if you see MGR/SSN, which is related to employee SSN, when we have MGR/SSN equal to SSN, this means this specific employee manager for this specific department. So we take this copy of employee as M, and when we have M.SSN equal department, which we called it D dot MGR SSN, then this employee is a manager for this department. So we connect between. Like this, we connect between department and its manager employee. And we connect between here, we connect between employee, normal employee, and its department by using department number with D and O for normal employee. This normal employee, this manager employee. Okay, we need to know that the salary of the employee not more than the manager. So this one will return if the salary of the employee more than the salary of the manager. We check not exist. We don't need this case. So not exists that the salary of the employee more than the manager salary. What will happen here? It's like creating a rule in the database. Now, anytime you are changing the employee tables, it will check this condition. If you change the salary, if you insert a new, if you are inserting a new employee or updating employee data, it will check if this query violate this condition, this assertion condition. So it will be automatic from the DBMS checked if you create this assertion. So it's like rule, you build it in the database to check the inserted data that applies this condition or not applying this condition. It's difficult to use the simple check for this type of assertion condition. Why? Because I need to check in the update. I need to check for the update. I need to check for the insert. Many things. If I change the manager's salary, it's himself also. If I change the employee salary, so it's better to make assertion like this. Okay, about the trigger. Also trigger, we will focus next lecture for triggers. We will give simple example here for trigger, but next lecture we will take more about the trigger. Triggers actually used to monitor the database and check some cases for the database and do some functions for the database. The component of the trigger, it's like the gun trigger, yes? When you speak about the gun trigger, you have event. What's the event for the gun trigger? You moved your finger and press in the trigger. We have a condition, and then depending on this condition, we take action. Okay, so a trigger should have event to establish this trigger, and then we apply condition to take some action. So a trigger should have event to activate this trigger. Then we need to check condition, and depending on this condition, we can take some actions. This triggers used in active database. What's the meaning of active database? Database that include event driven architecture, and it's respond for conditions and for event. PostgreSQL, most DBMS actually it's active active database, because it will respond for specific events. But for example, Excel, it's considered as database also, but it's not even driven, okay, and it's not active database. But for example, in Oracle, in PostgreSQL, in SQL Server, all this active database, because if you have events, and you can apply condition depending on this event. So you can create triggers. Okay. Actually, the standard for trigger, it's like this: create a trigger, this is a keyword, then trigger name, then you have before or after or some keywords to know the time, okay, for this event. Before insert, after insert, before delete, after delete, something like this. So you need to give the time for this trigger. You could apply this trigger for before or after specific events like insert or update of the database. We will see many examples because we will take more triggers inshallah next lecture. So here before insert or update, this means if we are inserting data or if we are updating data of the salary, we will check if the supervisor SSN, we will check here the condition. Here before update or insert of salary and super SSN inside on this keyword on employee. So we have attributes. We check if we updated this attributes for this table. Now for each row, also its keyword, when a new dot salary, select salary from employee where SSN equal new. New this mean the a new updated or new data or new inserted data. When we have SSN equals a new super SSN, so we will for each, this trigger will be applied if we have this condition. The salary bigger than the salary of the employee. I see something missing here. This example, let me check the book. Okay, let me check the book. Where is it? Anyway, until we reach the trigger in PostgreSQL, it's totally different. We have created trigger keyword, but what we can do here for create a trigger, we have function to be applied in specific condition. So we will use function. This means we have procedure SQL. That's why I delete this until next lecture. Why? Because we have next lecture BLSQL. We will speak about BLSQL in details. So this will get data from employee if the SSN, the salary, we return the salary. Okay, we return the salary from the employee if he is a supervisor.
Doctor, the syntax before insert or update, it is a syntax of SQL?
Yeah, here, this keyword.
Beneath it, under it, before.
And this is the name of the trigger. This name of the trigger, and this the event time of the event. So you have events before and after. Okay, then we have condition. We Then we said we have event, we have condition, we have action. We have event before or after update or insert. Then we have condition here. When specific condition. And we have action here. Let me check the action. The action is usually, but it could be that will be automatically executed. In this example, the action is execute stored procedure. Actually, we did not take stored procedure because we did not speak about procedural language SQL. So that's why we missed this one. When this action happened, when this condition happened, this is the meaning. We have event, we have condition, and if this condition happened, we will do this procedure. What is the procedure? Inform supervisor. And we give him the new supervisor SSN and the new SSN. What this means? This means we have a procedure to do something if this action and if this condition and event happen. What inside this procedure? We don't know what inside it, but I guess it will give like a message for supervisors that we have problem here. Somebody tried to insert salary for employee more than the salary of the supervisor. Okay, so this one is stored procedure, like a function, yes. So we will take, inshallah, next lecture the stored procedures or the functions like this, and we will take more example about the triggers, because we will start about BLSQL and what is BLSQL, especially in PostgreSQL we speak, and we will take example, then create functions, then we can use a trigger and call these functions. So we cannot start from the end to the beginning. We have started from the beginning with BLSQL. That's why I postponed this trigger until next lecture, inshallah, because we have the syntax in PostgreSQL different than this syntax. Okay. And we have to speak about storage procedures and functions in PostgreSQL before speak about the trigger, because depending on condition, we have to take action using function or storage procedure. Okay, about the views. We mentioned that views, it's a virtual tables in SQL. We need this view actually to make like this. You imagine that you have some joining that you need it many times. So every time you want to run this join, it will be a problem. Every time run this join to get result from this joins. You can make like a table. It's not really a table, it's virtual table to get data from this joining or from some condition, and you can use it as a table for select a statement or for to get data from it. So it's a single table. The view itself, it's a single table or a single virtual table derived from other tables. So it's like you are joining between some tables, not only one table, in single table. Okay, we considered it as a virtual table. This means it's not necessary to have data always. When you used it, you will get the data from it. So if you have a view that will present data from joining between employee and department, then when you select or use this view in the select statement, it will bring the data from the join table. So it's not like you have populated or you have data inside it. It's a virtual table. You don't necessarily have data inside it, but if you make any select statement for this view, you will get data from the result that form this view. We will see how to form the view to understand this. So we can create a view like we can create tables. We can give this view name, and from where the data of this view, it comes from a query. This query could make join between two tables, three tables, or even specific query to return result from one table. It's okay, but almost we speak about joining between more than two tables or two tables and more. So this view, instead of every time to connect between employee project and works on to get the name of the employee project and hours, now we can only one time create this view. After that, we can make simple select statement. Select star from works on. It will give you the names and the hours. Let us use this create a view example. Okay. I think here. Okay, I already applied this one. I will just drop it or delete this view. Okay, now we don't have any view. Okay, then we will create a view. Creative view works on as, so creative view, name of view as a result from select. Okay, let me just make it like this. So creative view name as this view will be as a result from this select statement or query. This query make joining between employee and works on and project and works on to get the name, because the name of the employee in the employee, the name of the project in the project, the hours in works on. So we are joining between them to get this result. Now, if we run this query, run another time. Okay, sometimes it's accept small letters, sometimes not. Okay, I will change to small letter. Just a moment. Okay. So let's run again. Okay, it's successfully run. However, the condition here, you see, it's amazing. Sometimes accept capital letters, sometimes not.
Maybe, Doctor, maybe the problem with the Virgin we are using for
I
Postgres,
don't know. Oh, I did too. Let me just drop this one also. It's okay. We have works on now. Let me select from works on. Just I want to close this creation. Okay. Select star from like any table. Now it's a view. It's come from where? It's come from a query as a result. So it's virtual table. It's a view. Works on one. Okay, run. So it give us the employee's name, project name. Okay, when you run the query for this works on, it will get the data from this result. So why that's why we said it's just what we called a virtual table. It do not have actually stored value or populated data inside it. But when you used it, it will get data from the original query. Instead of every time writing this query, the whole query, you can use this view to build some forms or something like this, like any table, but it's not really a table in the database. Of course, you can give new names. Here, we did not give names, so it will take same names like F name, L name, B name, hours. If you want to give name for the elements, you can use like this, create a view, view name, and you can open practice and put the names of the element. D name, I will name it depth name. Count number, this counting number of employees, so I will name it number of employees. Total salary. So in this select statement, we return each employee name with number of employee inside this department and average or summation of the salary for all the employees. So we have from department and from employee. Why? Because we have the salary and count number of employee. Then we connect between them and the group by department name to get for each employee. So the result of this query will form this view. Okay, how many slides we still have? Okay, we almost finished. Oh, why stopped here? Okay, I stuck here. I think the problem in this slide. Okay. Okay, we continue. Create a view. Then, as we mentioned, once you define the view, you can use SQL queries, or you can use this in SQL queries. Also, view is always up to date. You don't need to update the view data. Why? It's responsibility for DBMS. I said when you use the view, the DBMS will give you the updated data. You don't need every time to create this view. This is the meaning. When you run the view or use the view in select a statement in query, the DBMS will give you the updated data. You can use drop a view to drop any view. Just drop a view and a view name. Okay, then you will delete or drop this view. Okay, we have some statement to make some changing in the schema. Sometimes DBA, what's the meaning of DBA? Database administrator, the person that who responsible for managing the database after the design and implementation in the company or in the university, in the supermarket that will use this database system. They have one person that we called it DBA, database administrator. He have the most what we privilege, so he can make some changes for the schema if he needs this. After make this database operational, after using the database. So you can change some things in the schema after start using it, like use drop command. You can use a drop command to drop tables, to drop domains, to drop constraints, or even to drop the whole schema. What's the meaning of the schema? Actually, database could have some copies or more than one copies, more than one schema, depending on the rules and authorization. For example, some of the users will use this part. We called it schema 1, for example. Other user can use this part. So database is the whole database, and database could have more than one schema or maybe one schema only. Okay, so you can drop the schema itself using this one, schema, or drop schema, this keyword, drop schema, then schema name, then what's the option, cascaded or restrict. Cascaded, this means I will drop the schema even if it's have tables, even if it have queue views, and if it have any elements. If you use restrict, this means schema will drop only if it's have no elements. What's the mean of elements? Elements like tables, like domains, like constraint, like views. So you have empty schema, you can delete it using a drop if you use restrict. But if you use cascade, which is very dangerous, then you will delete the schema and its content, even if it's have or if it included some tables. So this is the difference between cascade, and restrict. So drop tables. Cascade, this means if this table have referenced by other table, you will delete this table and you will delete referenced value. If you said restrict, then if you have reference value like foreign key pointed to your table and you make restrict, you cannot drop the table. If you make cascade, this means delete the table and delete any tables that have foreign key pointed to your primary key in your table. So this is the difference between restrict and cascade. Okay. So, for example, drop table dependent cascaded. What this mean? If you have restrict option instead of cascade, the table will be dropped only if there is no referenced or foreign key pointed to your or reference to your table. But if you use cascade option, this means any view, any constraint, or any table, reference table will be also dropped with your table. For example, if you drop table employee cascaded, this means you will drop also the dependent table. And also you will drop the department table because we have MGR SSN in the department table as a foreign key pointed to the employee. And if you deleting department table, then you have to delete the project, and then you will have many problems here, actually, depending on the options that you choose here. Okay, alter table, this means change. Alter, it means change. You can alter table to change the table itself and add column or add attribute. You can alter that table or changing the table to a drop column, existing column, or add a new column, or you can change, for example, change definition of already exists column, like change the default value or drop the default value, or like change null or not null restriction for this column or attribute. Here are some examples. Alter table, this means change table, table name. What is the company? Company is a schema, dot table name. If you have one schema, then you can use that table name directly. So create alter table, this means change the table employee, add column, add a new column, which is job, the new column called job, and it's varchar 12, it's domain. Okay, alter table, you can drop existing column. I don't need the address, then a drop column address. Cascaded, this means if there is something reference to this address, it will be also dropped. Okay, alter table, department, alter column. So inside this table, we will change, alter, this means change, this column, which is manager SSN, drop default. So now there is no default value for manager SSN. Okay, alter table department, alter also change column manager SSN, set default. I set the new default value. So if I add now a new department and I did not give value for the column manager SSN, it will take the new default value, and so on. Okay, I think we almost finished here. About the drop, this means delete. We can drop constraint or add constraint. Same way, constraint, we already took it. You can return to constraint. Alter table, table name, drop constraint. So we here drop the employee super foreign key. So if you remember, we have employee SSN and super SSN, which is referred to SSN. Here we deleted drop. This means deleted this constraint. Okay. Also, we can add a new constraint. Alter table name, add constraint. Then, like you defining constraint, for example, add constraint X, Y, Z, anything SSN referred to employee dot or super SSN referred to employee SSN. Okay, I think we already mentioned these issues. This will summarize the SQL syntax. Okay, you can see create tables, table name, column name, and anything like this means optional. Okay, you can return to it. That's all for today. I will send you, inshallah, in the group details about the presentation. So see you, inshallah, next week. The presentation, as I sent in this link, it will have the schedule. This link has the schedule here, the date for the presentation, and the time. First time for first student, second time for second student. All the students should attend from the first presentation until last presentation. Okay? You should attend all the presentation.
Oh, okay.
Okay, from first until last presentation, every one of you have to attend the presentation. You need to submit the presentation until 28th of May. Okay, 28th of May, using OIS system, you can submit your summary for your presentation. See you next week, inshallah. Assalamu alaikum.
See you, Dr. Thank you.
عليكم السلام.
عليكم السلام.